all have internet connection? Yes, so yes. Okay. So what's the topic that you guys are now going to learn today? Are you given the title? Okay, come on guys. Like, if you're not going to talk, it is not going to happen because the set of topics that I plan to do today are very practical oriented, right? And if you guys don't talk, really difficult to get. So, do you guys know the topic? What is it? Sorry? Okay. That's not the topic. The thing is, you guys are supposed to have a lecture next week on the continuous integration, right? And for that, you need to know about the version control systems. So there's a bit of a, and because of that lecturer contacted me and asked if I can do this today, so that I can do the other one on some other day, because it's related. There's no point in learning about continuous integration without knowing about version control systems. This actually happened like yesterday, so I had prepared for previous one. Like it makes sense. So, any issues? Any problem with that? Like, so I actually before preparing for this one, I was actually supposed to come on previous day, and preparing for this one, I kind of did a background search on where you guys are, like, as in like are you into like heavily software engineering and or like are you like following a general IT type of a thing? And I was told that like half of the class will be from software engineering and the other half will be on general computing. Is that the case, or like is it different? All of you guys are into like software engineering or software engineering? That means like everybody into like hardcore development. Is that the case for everybody? Okay. So that would mean since you guys are like both these students, you guys have done at least like several projects by now, right? Okay, so the topic is version control. I don't have that many slides as such because I intended to do this in a different way. So anybody who doesn't have internet connectivity, that will be the easiest way to get the answer. Everybody's having the okay. So to start with, why? Can you raise your hand where you have like worked on a multi-user project? Sorry, multi-developer project. Yeah, there are multiple developers got involved and like work on a project. Can you guys raise your hand like if you have worked on a single project? So almost everyone, right? So what is the average developer count? Sorry? Pick up, pick up. 6? Sorry, can't hear. How many? 6. Is that a realistic number with anybody? Is that the usual group size? Because I usually look at monitoring and their group size is usually 4. They don't go beyond that. More during the class size or something, but I've been doing that for several years and they never go beyond 4. Maximum 5. Okay. Now that would mean you guys have shared pieces of code software that you write with one another. So before that, tell me how many have used SVM subversion? 1, 2, 3, 4. Git. 1, 2, 3, 4, 5, 6, 7. You guys haven't used anything? You guys haven't used anything? You haven't used any subversion only? No? What about, have you used subversion only? No. You? No. Okay. So then how have you shared code between one another? If you are working on a group project. Sorry, you have to speak up. Come on, you guys are 4th year students, right? Don't you think about getting a job if you can't speak in a public environment? Sorry? Kid. Okay. Anybody who hasn't used Git or SVN? Then I think I don't need to emphasize on my factor because basically this is something that I came across. Okay, by the way, typically these are the set of topics that I have been asked to cover: GitLab, Stash, and formerly Bitbucket, SVL, TFS, Team Foundation Server, and Slack. Now, those are publicly available projects or products. Right? You guys have been notified of this before? These set of topics? Have you been told about this? These topics? No? These are the topics that we are going to cover. So this is the list that Amita sent me. So now all these things are projects or products that are available out there, right? So and there are plenty of material on these things out there. So the style that I'll be using is I have collected a bunch of URLs, right, which highlights some of the important things about this, right. So I'll be using those URLs, so the sites wouldn't have that much of point forms or any material unless I figured I thought very important to have a diagram or something like that. And then since these are public material, there are plenty of things that are on these. I wouldn't go into lot of details unless you request for anything specific, but rather show you certain pointers on how to learn, on not on specific stuff. So this is something that actually read last week. I thought this has two more important things that are related. So basically, this article tells there are 7 or 6 points that it discusses. Not everything is related, but I thought this third point is important. Right? The right of collaboration. How do you guys plan to do like higher studies after the degree? Uh, so typically, like when you go beyond the degree and go from masters or PhD, what you do is you end up extending what somebody else has done, and that will lead into like different research topics. So the rise of collaboration has increased significantly over the last few years, right? And probably your generation wouldn't feel this because you have never gone through this era, I believe. So this is the history of version control management systems. Right? So SCM is actually a different term that covers a broader perspective. Anybody who knows the difference between the SCM and the version control management system? VCS, version control systems versus SCM. What does SCM stand for? What is it? What does SCM stand for? There's something in front of a laptop. So SCM stands for there are like different definitions, but like one is source code management, but in this context it's source configuration management or software configuration management. Okay? And version control systems or version controlling is sub part of the configuration management. And this particular diagram, which I picked up from here, kind of shows how some of these systems evolve over time. And at the bottom of it, like we have like something that you know, like how many of you have seen these phones? Not these ones. Probably you guys haven't used any of these. So now, internet actually started becoming very strong somewhere here, 1996 era. And now the need to collaborate, like the definition of collaborating drastically changes probably somewhere from this point onwards. Like previously, yes, people worked on software projects, right? And there were different source code, version control systems, right? Like RCS, PVCS, ClearCase, but with the intent of internet, right? These repositories, these like ways of managing software versioning became public. So, for example, like when you go into this particular era, right? There are many version control systems like Git or SVN that you have used that are all public. Like there's a public version that you can use, or rather a hosted version that you can access through internet. But like the case with some of these systems, for example, like out of these, I have used CVS, I have used VCS, Visual Source Safe. I have used ClearCase to a bit. You never had a public VCS server. Nobody, like back in 90s, you never talked about having a public VCS server. Just compare that to having a public SVN server or public Git server. Okay? So VCS is like it's basically something that came with Microsoft platform. It was tightly integrated into Visual Studio. Even now, like it is, but those days, like Visual Studio, Visual Basic Editor, everything was tightly integrated. And CVS is concurrent versioning system. yet another very famous version control system back in those days. So if I can remember correctly, it's a famous Linux distribution that name it's my mind. But what I wanted to highlight here is now from this point onwards, like 1996, 1997, 8 period onwards, there became a lot of boost in how people collaborate, right? In general, right? So maybe it could be how people share news. It could be maybe due to how people write, how people how newspapers work, right? Same thing got applied into development as well. So because of that, the need of different ways of collaboration and different ways of doing version control of different things. This doesn't get applied into source code only. So it can be anything. It can be an article that you work on. It can be a news briefing that you are writing. It can be a configuration that you are maintaining to boot up a server. Right? So different systems came into the picture, and then different of these systems try to solve different problems. Right? So this is how many guys have read about SVN versus Git? I'm not going to ask questions on that, but at least if you guys have read about SVN versus Git. How many of you guys have worked on both SVN and Git? Okay. Anybody else? On both SVN and Git? Okay. So it's a very natural question. If you have worked on both SVN and Git, why there are two systems like this? Okay, so going back to this particular article. Now, the rise of collaboration, right? Because of that, there will be more and more systems that deals with the problem of because we are talking about version control system. There will be more and more systems coming into this space, solving different problems. Because SVN, Git, or any other system is not perfect. They are not solving all the problems that are out there, and people are doing stuff on the internet. So, how many guys are fans of JavaScript or using JavaScript? Why brought up the topic of JavaScript is unlike many other language, JavaScript seems to be having a lot of framework libraries implemented, right? And most of them are a result of Git, because Git has a way of encouraging natural development, because people can make a copy of a repository and start working on their own stuff. And the way JavaScript has evolved, JavaScript libraries frameworks have evolved, has a very tight connection to what Git is supporting. Okay. Anybody has heard about Slack? Anyone? Slack. Anyone else? Slack. You guys have used it for a project or How many got in all? Now, so out of these list of topics, I thought of starting with Slack, because Slack helps us to communicate. Okay? Now, if you guys can go into slack.com in your browsers, right? These, like, I'm going to do this in a practical way. And one of you, okay, maybe like I'll ask him to like, can you create a new team? Tell like something, it has to be something unique to this group, this particular group. Once you create it, you have to let others know. So basically, while that is being done, like, just go to Slack and see what it is. Now it says messaging app for teams, right? So you might wonder, isn't the email doing the same thing? Right? But email is more of a like a way like where you like enter some text data and send it to another address. Right? The difference between Slack or many other systems like this is like they are more structured. They allow you to enter content, right? Maybe with some structure like a tag or like a hashtag or with some classification. Classification is the word, right? So that you can relate things. Right? How many of you use Stack Overflow? Use as in like, okay, not on the read-only side, but like, have you guys posted questions? How many have posted questions? So basically, like when you post questions, like you put certain hashtags so that there's a relevancy and it gets applied, right? And similarly, Slack also has the same concept. So basically, you create a team. What's the name? What's it? S. Sorry, didn't hear. SE.
Essence of Engineering. C group dash UCS.
UCS. Okay. Then the others have to sign in, right, and try to find that group. You have to do the moderation. SC, divide
C group dash UCS.
Anybody has to run it? If you haven't signed up, you need to sign up. Sign up using your
I think I have to invite everybody first. Because she's getting a message saying
but you can ask for you can request for it. Basically, he is allowing what's your name? Manager is allowing anybody having a Gmail address to be able to sign into the group. Right? So if you guys don't have Gmail addresses, right, just give him the domain name so that he can enter that domain name as well. So if it is Yahoo, just tell him, because like by default he has entered Gmail addresses only. Correct? All of you on that side? think there are like half the class still needs to join. Can you guys quickly join? How many are still pending to join? Everybody join? You can only see, okay, there are 23. Sorry. Now, basically, this is a, now, by default there are like 2 channels that is created, general and random, and I just created a new channel called links, right? So basically what you will do is you would end up like creating a channel like this, right? And the purpose is this is like a hashtag. This is a hashtag. So you put up a like a topic that is relevant, and then you post messages into that tag, right? So I don't think like can you guys see messages in this link? Yes. I haven't invited, but you should. I made it a public channel so that anybody can see messages. Can you guys see this? Links. So if you go to channels, right? You should be able to see this, the link that I have just shared, right? So now there are like many other options that are available. I just like explore on your own, right? But this is a very good way to like communicate when you are like working in projects, right? Different projects. Let's say like you get into a final year project, you get into a group project or anything as such, right? Slack is it's actually like I can't remember when this started coming up, but like probably like I first started using this about like 2 years ago, right? And it's gaining popularity because now if you compare to an email system, let's say like you create a bunch of email addresses and start collaborating with each another, right? Now emails are not structured. Structured as in like you just enter some random set of topics, right? And now Gmail of course offers different ways of searching, but here it kind of allows you to like have a more structured conversation so that you can put different hashtags so that whenever it's relevant you can go into the particular channel and figure out okay what are the messages, right? And you can even do something like this. You can create a, let's say like among yourself, like there are 23. You can have a public team, right? And within that you can create sub teams so that like for various project stuff, like if somebody wants to communicate something general, you can use one channel. For team levels you can have different sub teams, right? So it's a good way to communicate between team members, right? And many software teams are using this. I don't have the statistics, but like many teams are using this. What is the size in your internship, like the team size? Okay. So basically, like it's very effective because you start seeing messages popping up and okay. Any questions on this? So just like a piece of tool, so just go in and figure it out. But I just want to like give you the concept of like group communication. So there's now the other thing like this I'm going to mention like when I'm talking about Git, SVN and everything, right? Now there are many alternative tools, like if you talk about Google Groups or Google Hangouts, it is doing the same thing, but like maybe having slightly less features. So like, there are competing tools. There are like tools having equivalent capabilities or like maybe more. Okay? So this is just a tool, right? So it's up to you to use it or not, but something that is upcoming and something that is gaining a lot of popularity. Any questions on this? Okay, so then is there a public SVN server that you guys are using here? Like, so okay, now if I ask you like this, like everybody familiar with the concept of like an SVN repository and everything, or are there like there are other people like who are not familiar with SVN repositories? No, because I'm asking because like you guys have worked with Git and SVN, there's no point in like going into like fundamentals, right? From which you check out things, right? So first of all, to start with, an administrator would go in and create a SVN. So first of all, you need to install the SVN server, and on top of it, you go in and create a repository. Repository is equivalent to a folder, right? With some configuration details, right? You go in and tell, okay, let's say you are working on a new project called some image recognition, right? Let's say you want to recognize images of players who are in the ground, right? You say like player recognition project, right? So now that is a project that you want to work on, right? But there could be multiple other projects that you are having in mind, right? So what an administrator would do is like what he did on the Slack channel. That person would first of all go in and install a SVN server, and on top of the SVN server, he would create a repository. Inside the repository, you can have multiple projects. So this player image recognition can be one project. Right? Then now that is the central server. So anybody who wants to work on that particular project, right, would take a checkout. So we go here. Now this. It's called SVN Redbook. If you go in here, you would see so this shows you how to go in and create a repository. So this one is share the link. Now you might see the term here, total is SVN, right? Now, SVN is the original piece of software, right? But after that there came different like companies who picking up idea and like developing their own server and the client version of it. Right? Now, like I said before, it is a server-based thing, right? So if I this particular picture, this is the main. Just look at this part now. This is how the SVN world works. There's a central repository that an administrator would create, and there's a URL for this repository. Okay? So once the repository is created, the administrator will tell, okay, this is the URL of our SVN server. And once you do that, like this is an average engineer developer working on a project, right? He or she would like take a checkout of a particular project from the central server. So there's a centralized server concept in the SVN, right? And there used to be Google used to support centralized SVN servers up until about like last year, but they stopped it. I think like last year. Google project is there's a Google code. There's a Google project called Google Code. It was basically supporting creating public SVN, Git, and Mercurial repositories, but with the improvements and with the popularity of GitHub, they basically stopped Google Code. So now you can't create repositories, but all the previous projects are available. Now, basically, you have a central server, and so this central server, first thing that you would do is you would go in and create a repository. Okay? So this is how you would go in and create a repository. Okay. Now, before going to this one, I was going to tell us now this particular concept got picked up by many companies. Right? So because of that, like you would see various SVN servers and clients, SVN servers and clients being developed and sold by various companies. So Totis is one such company. Now SVN is a complete command based thing, right? But Totis has a server manager and a repository manager, and a client tool as well, a visual client tool, right? But you don't need to have Totis installed on the client side to like work on SVN repository. Right? So basically, there are commands that are available. So now in here, I have SVN installed. So it's a command line. Okay, leave not anything because I didn't. So basically, it would tell me like what to do, like how to check out. All those commands. So this is the command syntax for the checkout. So I do SVN CO. So it would tell me what is the syntax for checking out from SVN. Right? Now, what I was asking before was like, do you guys happen to have any public SVN in the university? Because for Git's case, there are public servers, but not for the SVN's case. No public SVN. There are certain, like after Google project, there are certain other public SVN servers, but those are not popular, so it requires a sign up. So I will go in there. Now, the command set would be something like this. So first of all, you would start by checking out. Right? So the syntax for checking out is something like this. So SVN checkout and the URL, or even this CO is a shortened form. So here you would tell what is the URL of the SVN server, and when you check out a certain project, right, if you want to add a new file, what you would do is you would add a file by telling svn add. This is how you would tell that you have added a new, that you are going to add a new file to svn project. Then there are like certain properties that you can set for the whole svn project, right? Now and delete and checking the status, getting update from the server, doing a diff. So basically you can do a diff between the copy that you are having locally or with, from the server, right? Now what happens in SVN is like whenever you put up a change, it goes in as a revision. So there's a revision number associated with each and every change that you commit into the server. Okay? So now this particular example, what it does is SVN diff minus R is for revision, right? Between two revision versions, sorry, two revision numbers. And this would give the difference between those two commits, basically. And move is for like moving one file from another. Right? There are like plenty of resources like this. These are actually not super good, but anyway, just share this. Okay. Any questions? Anything? Now, with that brief introduction about the SVN, right? I just want like compare the difference, main difference in the Git world. Right? Now, in the SVN world, there's a central repository that is available, but this is not the case in the Git world. In the Git world, there's a you don't call this a central repository, but it's called remote repository, right? And somebody creates a project in there, right? What you do is you take a copy, you take it, the term that you use is you clone. You clone a repository, you clone a remote repository into your environment. Okay? So basically within your environment, you are having the complete repository, a complete copy of the remote repository available for you. Now, this is what when you read about SVN versus Git, right? You would see a term called decentralized repository. That is what it means. Your code is decentralized. It's available on multiple repositories locally. And the other thing is we will do some of this in the command line. There can be certain repositories to which you don't have commit rights. So the concept there is now it can be here. You have the remote repository. If you want to like send in some changes, those changes are called PRs, pull requests. Okay? But to do a pull request, what you have to do is you from the remote repository you do a fork. It's called fork, fork, and you work on the fork, and then you send a PR. Okay. Can you go to github.com? and sign up from some. So I believe most of you are already having some repository on GitHub. Like anybody who's new, like who's not having any repository at all. Anyone not having any repository? So basically GitHub offers two types of repositories. One is the public repository. So if you just go in and create a repository, that usually is public, right? But if you have the paid account, there's a private repository available as well, right? Which is the difference between the public repository and the private repositories. Private repositories are stay hidden as long as you pay, and there used to be a restriction called you can only have 10 or 5 private repositories, but they have now lifted the restriction, so you can have any number of private repositories for a paid account. The moment that you stop paying, the repositories are gone. Like gone as in you can't access it, and that is pretty much the main difference. So in this particular case, like I have so I'm part of an organization. So like if I go to WSO, like because I have been added to the organization, I see all the repositories that we have in here, and all the engineers who are working on different different repositories, right? And here, like I have like committed to very few set of repositories for anything else. If I want to like send in a PR, I need to like hook and then a PR so that somebody who's having a commit right can commit it. Now this is something that is fundamental difference between the Git and any version control system, right? Like Subversion. Right? So basically, the difference is like the data, right? What happens is like if you go in and change like this. So what it says here is most of the systems like Subversion, they store information per file base. So if you in SVN, if you go in and change a file, right, those modifications are stored at a file base, versus in a system like Git, they are at a repository base. So if you when you check out a Git repository, you are getting the whole set of changes or modifications that have been applied on that complete repository. Right? Now, this is one of the plus arguments against SVN versus Git, because you can work remotely. So basically, in the SVN world, if you want to see the differences that I've applied to a certain file, right, you have to do a SVN log, right, that will execute the command on the server. So literally, you enter the command SVN log and the file name on the command line, and it will get executed on the server, and it will give you a list of revisions that have applied. But in the Git world, it doesn't go into the server, because the moment that you do a checkout, like of a Git project, Git repository, it actually like brings all those changes, and that is available under a hidden folder called .git inside your Git repository. So if you actually open it up, it's a hidden file. It has all those differences written in a certain format. Now this is a fundamental difference that you have to know if somebody asks you what is the difference between Git and this thing, Git and SVN, right? And at the same time, this central repository versus distributed repository is again a fundamental difference. And this is actually something that is good. I'll share this. for some reason so these steps are now I'm going here. Now basically this will show me the repositories and this will show me the number of people, the teams and everyone. So if I go into a particular product, let's say so it shows me the history of what has happened, right? Now here there are multiple branches that you can count. So let's say like now in this case there are only 2 branches. The purpose of the branch, like you guys all know, I believe like is like if you are working on a complete new change, right? What you would do is you would end up cutting a branch so that you can continue working without disturbing the other team, right? So in this case there are 2 branches, master and 206, right? The other concept is the tag, the concept of a tag. So tag is a way of going back to a particular label state. Now in this case, like before doing certain release candidates or different like betas or like different alphas, you go in and create a tag, right? So that for some reason, let's say like today you do a release candidate, right? And that release candidate like goes on for like 2 weeks and you end up like continue working, right? And somebody reports a bug or like you have given that into a customer and that customer like reports a bug telling, okay, I have been trying out with this particular release candidate and I encountered this particular bug. Can you look into what has happened, right? Now how to go back to that previous how to easily go back to that previous state on top of which we release the release candidate. Tag is the easiest way. So you can, once you tag it, you can check out the stuff using the tag. Then the other important concept is like it shows you can do the release management here. So basically, for a given project, you can create a release, right? So that cutting a release also includes creating those tags, and the whole process can be streamlined. Right? And here I see 4 pull requests. Right? Now these are the pull requests that others have sent in, right? Others who like maybe not having commit rights, or maybe others who want to get a certain change review, right, before being committed. So there are 4 pull requests. So if I click on this, like it would tell me what are the files that it has changed. Right? Now in this particular case, there's only 1 file, but like a typical pull request can have many number of files changed. Now in this case, it shows me what are the differences. Now this is what I have, right? And these are the changes that have come in, right? So in the form of a like minus and a plus. And a typical in a typical organization, what would happen is now there are actually 2 approaches. Like one is commit and review and commit. So there are like organizations work on those 2 models. Right? In commit and review approach, so basically like anybody can commit anything, right? But there happens frequent code reviews where like you go through commits that has happened like for a selected period of time. Right? In that case, the development is fast. Right? The other approach is review and commit. In that model, this mode of pull request is helpful because you see all the things that are that have been submitted. Right? You go through each of these, right, and then figure out. Okay, so for example, in this case, like I would start reading this code. Okay, now this is a test case. Now basically I would see, okay, this line has been removed and this line has been added, right? So then I also see what is the difference. Right? this exception is being thrown. Likewise, like you review the code before the commit, and typically what that means is there's a permission model where some can commit, some can't commit. Okay? Now, this is a place where SVN and Git again differ. Right? Now, in the case of Git world, you go into a remote repository, you clone it, and you have everything together within your machine. Right? Now, in that case, it's very difficult to centrally control permissions because everything that you need that is available on the remote repository gets cloned in here. Whereas in the SVN world, since it's a centralized server, you can apply permissions to different paths. You can apply visibility restrictions, you can apply read-write permissions into different paths. So this is something that differ when it comes to SVN and Git, right? The original Git implementation. But then, like I've said before, on top of the Git concept, there are like different implementations that supports these type of permission restrictions as well. That's what GitLab is all about. So there are different statistics that are available on what happened, and you can fork. And this also has issue management, right? So basically, like if you are working on a project, right, and you can use the GitHub itself to manage issues. Let's say like for your final year project, like you get like 2-3 like members of you get together, you can actually use the GitHub's issue management system to like report issues and resolve. Right? It will actually like be really good when you finally present your project, because like then you can showcase what you have done, right? So that's the next point that I want to tell you. Like when you are presenting your project, final year project, or like it can be any project, right? If you fully utilize what is being provided by, okay, let's say Git. I'm not like pushing for Git, but if you happen to use Git, what is being available or presented by Git, right? You can actually show or give an impression that you understand the software delivery life cycle. Right? So to start with, one is like if I go to code, right? You can tell, okay, you start with a certain level of idea, right? You start developing, right? Then you figure out, okay, there's a major refactoring that needs to happen. Right? You can go in and create a branch and tell, okay, for this particular, in order to facilitate this particular change, we created a branch. Then, like, let's say, like, if you are like creating a bill, or if you are creating a output every week, right? You can go in and create a tag, right? And then you ended up like creating tags for different purposes, or like you can name the tags in a meaningful way, and then have a documentation that tells what that particular tag is all about. That is on the code level, right? Code tab. On the issues front, you can actually maintain all the issues that you encounter on the project here itself. Right? Then now when you do this, you can actually when you click on the new issue, you can enter all these details and you can assign different files that are available on the Git repo into this one, so that you can relate. Then you can if it is applicable, you can go for a pull request model, right? But now what happens is, like, once you merge all these pull requests, like those will be gone, so you can't actually show those as statistics when you're presenting something. But like if it is a work in progress presentation, right? What is happening right now type of a thing, you can actually show a couple of pull requests telling, okay, these are yet to be reviewed. and apply. Then you can use the wiki here to document your stuff, right? To tell like what is happening, and then basically as the sole documentation for your project. Don't go for a a different system or a Word file or anything as such, because these are online maintained revision control thing, everything together. Then basically you can show these two are mainly on the statistics, right? Now you can use these pulse and the graphs to show what happened. Now this only gets applied if you are very methodical in dealing with your project, like, because most of the teams end up like working on the projects latter part of the delivery cycle. But like if you are really methodical and if you have planned everything like in a way, you can actually show like what happened, because like these graphs are very detailed. It will show you like what happened over a period of time. Right? So in a real software company, we can actually by observing commit patterns, right? By observing issue patterns, we can actually tell whether a product is ready to be released or not. Right? There's a usual pattern. This is true in WSO2, but like in anywhere else as well. Like when we give a pack to the QA, quality assurance team, right? There's a pattern that like there comes a rapid increase of the issues, right? Then developers start like fixing those, so there's a decrease, and at the same time like QA team like start reporting more and more issues, and eventually when the product is ready to be released, right? There's a known pattern where like it gets decreased. The time between two issues get more and more distant, which would mean like finding an issue takes a lot of time. In other terms, can be interpreted as okay, the product is getting stabilized. Right? Then the type of the issue, right, gets more severe. Right? Typically, you wouldn't end up like having a very basic level of like, so basically on an issue tracking system, you guys have used like anything like, anybody has used Jira or like Bugzilla or anything? Anyone who has used like, who hasn't used anything? Okay. So basically like there you can assign different categorizations, right? Or priorities, right? Or severity. Now you can tell like how many severe issues are there and what is the time gap, right? So there's it could be that you have already set a release date and you are working towards it, right? But if your product is not really ready to be released, it is available as a statistics on the system itself. It's you will realize this when you go into the industry and like work on a particular project for several years. What I mentioned is like kind of true, because that is actually one measurement used by like project managers or engineering managers to like figure out whether the product is actually stable. Okay, so I was basically explaining like how you can use GitHub, right, as a complete package to manage your final year projects, right? Starting from issue code to documentation to even dealing with members, etc. This is only if you are like working on a genuine project, because like there can be cases where like I have like mentored and I have like reviewed projects where like some commit on behalf of others, etc. So those type of things cannot work in here. And then this actually shows the data. Okay. Any questions here? So the fundamental thing is like now start using SCN, start using Git. Right? There are like plenty of tutorials, there are plenty of sample projects that are available. Right? Just get a feeling of what it is. Of course, like there are like very advanced topics like when it comes to these systems, like on how differences are maintained, how to on administrative front, how to recover, how to do various things. But when you take the product as it is, when you take the concept as it is, you can actually start learning about it with a very basic set of commands, very set of steps, okay? So that you know what Git and SVN is. If you don't know, then comes the other one. So if I step back for a minute, right? Git is the original piece of software. This was done by Linus, the author of Linux kernel. Right? So basically, he used Git to host Linux source code, right? Linux kernel, which is like 2-3 GBs. Right? Then what happened was Git was picked up by various other companies, like in the SVN's case, and different companies started offering different offerings on top of the Git concept. Right? So what GitHub is a it's a hosted offering of the Git software. Right? So that's the difference. Right? Even on the SVN world, or CVS, we used to download the server and install it and run it on a local server on a university, right? So that there's a public Git or public SVN server for the university. Right? But that is that particular need is no more with the GitHub's concept. Right? But not many. I mean, actually, I have a link somewhere here. Even though Git is very popular, only 33% of the projects are using Git. Still, 44, I can't remember the exact figure, but some 40 odd number is still using SVN. Right? So even though the Git seems to be something hot, right? It doesn't mean it gets applied in every case, especially on the permissions case, right? Especially on things like now, if your team is not distributed, right? If you want to centrally have a control of more updated control of what's happening, right? Git mode of operating is not going to work, because people will have their local copies, they will keep on changing, and maybe they are sending PRs every week, which is it can be too long. It all depends on the project requirement. Whereas in a SVN world, you can actually tell, you can enforce a rule telling, okay, you need to commit every day, you need to commit as often as possible. Now, and at the same time, it's now, even though hype can be towards Git, you should not get biased towards any of these things. There are differences. Just go through the differences, understand what it means. So for example, things like Git repositories being false. This is something very common you would hear people tell, but so there are many things that are being explained with certain reason. And this link actually has a lot of valuable stuff on basically the differences between the Git and SVN, right? This is again this should be added to the list that I'm talking. Now the directory structure in a SVN, so basically you would end up creating the same concept of branches and tagging are there, right? But the organization is different. Now on Git we saw something called master. Similarly on SVN the structure is called trunk. So basically you keep on having the data stuff on the trunk, and whenever you need something special you go in and create a branch, right? And the semantic would be, inside the project you have a trunk folder and you have folders for different branches. Whereas on the Git world, the folder structure doesn't change. Now this is the hidden folder that I mentioned. The folder structure would remain the same, and this folder would contain a representation of what has happened, and Git's internal logic that figures out what to show us based on what we select. Whether we tell okay check out master or check out branch, it will show us what is required, and then there's a difference between subprojects. So subprojects is you have a different project somewhere else, and you have a way of including that in an inline way. So basically, in its world, SVN's world, it's called SVN external. So within SVN project, you put SVN external. So whenever you are checking out SVN project, it pulls stuff from the external project the repository as well. Whereas in Git's world, it's called Git submodule. And on SVN world, you can't change the history. Basically, every change that you apply gets added as a new revision. Whereas in Git's world, there's a command called git rebase where you can go back to a previous commit and change it. So that's again a fundamental difference between these two models. So, couple of similar tools, like there used to be something called Mercurial. There is still Mercurial is there. CVS is very old, like not many active projects are using it. But there are like commercial set of tools like Rational Clear Case, right? And Golden Star Team. Then there's the other one called the one that I'm supposed to cover called Team. T Foundation server. I haven't worked with T Foundation server, so I can tell you what it is. But I actually have I went through it. Basically, it offers you like the communication, the versioning control, and everything together in a single package, and it's tightly integrated with Visual Studio. I haven't worked with it. So, GitLab. Now, this one actually has very good comparison of what GitHub and GitLab offers. So basically, it will show you that the user interface is nothing much of a difference, even though it says here, right? But these are some of the noticeable differences, like protected branches, authentication levels, right? And then you can actually have a concept called work in progress. Now, in a centralized server, now this is actually not even available on the SVN, but this used to be available on things like Visual Source, Microsoft. You can actually lock a file so that people can't commit into that one, right? Now, none of these centralized SVN or the Git model, they can't support centralized systems. But in this case, like what GitLab has done is they have written a extension on top of it, so that if somebody is trying to commit one thing, like somebody can mark that particular file or folder as locked, and then if somebody is trying to override it, it will not be allowed. So these are the fundamental differences. So basically, GitLab is just another company offering improved version of GitHub. And in turn, then coming to the last topic, that is Stash. Now, for Stash, I thought I should play this particular video, 1-minute video, which is now Stash is actually again these are commercial tools, right? This is from Atlassian. Okay. So Atlassian is the company behind Jira and like many other products that are like very developer friendly, right? So this would like give you a, even the topic says
even in a distributed world, you need one place where all that code comes together. One place to host the source code for your projects, and the repositories related to it. One place to control who has access to your code, and easily contribute to a project. One place where you can track what is changing in your source, and then share tickets related to those changes. One place where you have full control. This place is Atlassian Stash.
So if you guys have played around with GitHub enough, you might wonder like the difference is basically it's at least like from my perspective, it's the tight integration with the Jira. So basically you can put in things like the Jira ID on a commit or a commit, right? It will automatically show you the links and everything. Right? So basically they are just like doing a tight integration among their projects so that like things are related. Like basically like if somebody is using Stash, they would be naturally motivated to use Jira or vice versa. For code reviewing and different purposes. So, but other than that, it's a commercial offering. There's no free version of this one, but something that is being copyrighted, but expensive. Okay, and the additional thing that they offer is like on top of the GitHub, they actually call themselves a repository management for enterprises. So that's like even if you go to their marketing material, it's like says built for Git, focus on enterprise. So basically they are like target is the enterprises, like large enterprises who are dealing with source code to offer a management better way of managing some, but not for individual projects. So like projects that are having small number of engineers. Okay, so this pretty much covers like the topics that I like assigned with. Basically, like how you can like take on from here is like if you guys haven't worked with any of Git or SVN, just if it is Git, the easiest place is go to GitHub, create yourself an account and just use it. If it is SVN, you can actually download SVN and install it and run it as a server. There are like couple of publicly available SVN servers, you can even use that. And get yourself familiar. So basically just install SVN client, create a repository, do a check in, check out, go through the history, everything. Do the same thing on the Git, right? And then there are like a couple of advanced Git clients as well. Then the next most important thing that is not included in the list, but I thought that should be mentioned is merging tools, right? Because like now the simple pull request that I showed, right, is actually showing me what are the differences, right? But now the large pull request can be like significant amount of files, right? And if you don't have a professional tool to merge, it will be very difficult to do that, right? So merging is something that you should know, like when you go into the industry, because being used very well, not very well, very much. Then the next topic is like the communication is important. Like so, Slack is just one way of doing that. I'm not sure like if we have companies in Sri Lanka that is using Bitbucket, Dash is Bitbucket. It used to be residing in a project called Bitbucket. But the next most important thing is like having the source here and focus on the continuous integration. Probably that will be covered in the next section. Basically, you have source on a central place, right? And having automated stuff so that like things can keep on happening and things can be automated while engineers work on different paths. So just try to like link those pieces together, right? And most importantly, like if you haven't worked on Bitcoin experience, do that. Like it will take like 1 hour max or like 2 hours to learn the fundamentals and start using it in one of your projects. Okay. Any questions? So like all like you guys are interested in WSO, like all WSO repositories are in GitHub for the source. So basically, if you go to github.com/WSO2, like all our repositories are listed. So just feel free to like check out clone and like find issues, even like send PRs. We'll help on those. Our issue tracking system is Jira, so just go in and create an issue and link the PR into that one so that we know like what the issue. Okay. Thank you. Okay. I actually ask you about this. Now, for the next one, like what I planned is like doing a small project, right? And I wrote the project in Java, right? So everybody familiar with Java? So basically, like what I want to do is like just use some EC2 offerings and show like what can be used in EC2 to do rapid development and cloud-based. What are the cloud-based software that you can use in your projects and you need to know